Example 4. It says evaluate limits as theta approach pi over 4 of cosine of 2 cosine square of theta minus 1 divided by cosine of theta minus sine of theta. As you can see, the first thing you should always try is try to plug it in, okay? You gotta make sure you know where pi over 4 is. So for example, so that means we're gonna make sure we draw that out. Let's draw it out a little bit, okay? So this is the x and y coordinate, but we're gonna use that as for the unit circle. So pi over 4 is 45 degrees, right? So it's about halfway. So I'm gonna write pi over 4 here. And if you recall, your coordinates for the unit circle at pi over 4 is root 2 over 2, root 2 over 2. All right? So if I were to, so that means if I were to look at cosine of pi over 4, that's going to be the x value of the coordinate, which is root 2 over 2. And if I look at sine of pi over 4, that would be root 2 over 2. Yeah? So that's what I have. Well, if I'm looking at this one right here, cosine of pi, which is, cosine of theta, which is pi over 4, that's root 2 over 2, subtract root 2 over 2. So right away, I know this is 0 right there. You guys see that? Now, if I'm looking at cosine square of theta, well, cosine square, let's write it over here. So this is 2 cosine of square of pi over 4, right, minus 1. And that's going to be 2. Cosine of pi over 4 is root 2 over 2. Now, you got to square that, and then you minus 1. You have to square first, by the way, yeah? So then that means I'm going to get the square root of 2 square is going to be 2, and then 2 square is going to be 4 minus 1. Well, that's going to be 4 over 4 minus 1 will make 0. So in this case, you have indeterminate. Do you guys see that? Now, why is it important to know that this is indeterminate? Because like I said, later on in Unit 2, there's a shortcut to finding the limits if the form is indeterminate. Is that okay? And because of that, you got to make sure you know if your limits have that kind of form. But right now, this is indeterminate form. Yeah. So we just have to make sure we write that first. Okay, and then again, make sure you know that the indeterminate form is that form of 0 over 0. I'm going to put it like this, so you sort of know that this is what it means. The problem, though, is that we cannot write it this way, okay? I can write it like that so you can see and visualize what it means, okay? But actually on paper, it's mathematically incorrect to write it, okay? So just make sure you know. So now that I have that, I want to make sure I can rewrite this so that I don't have that situation of 0 in the denominator. So to do that, I'm going to rewrite that 1, okay, that 1. So in the previous example, we know that 1 is the same as sine square of theta plus cosine square of theta. That's that 1 that we're talking about. Cosine of theta minus sine of theta. Like that. Okay, so that 1, you can replace it. So now that I have that, I'm going to write this. The limit as theta approach pi over 4. So 2 cosine square of theta minus cosine of theta will give you cosine square of theta, right? So 2 cosine square of theta minus 1 cosine square of theta is 1 cosine square of theta. And then this is going to be minus sine square of theta. And then on the denominator, this is what I have. Once you get to here, you can't really cancel it just because they're the same. This is cosine square and this is cosine, okay? You can only cancel when you have factors. if this is separated by a multiplication, and this is separated by a multiplication, then yes, you can cancel. But because it's separated by a difference, you can only cancel if it's a factor. Factor mean you're gonna have to put this in parentheses. You can only cancel the entire factor, okay, not individual terms. So what that says, we're gonna put this in parentheses, and we're gonna factor this out. So hopefully you remember how to factor this. This is a perfect square, difference of square. So when you factor, your sum is 0. That means, I don't know if I'm gonna write down here. I don't think I have enough space there. So that's gonna be cosine. Probably have to be bigger, huh? Yeah?
When we first started, we got 2 cosine squared of theta, but then where does the 2 go?
Well, you have 2, you take away 1, so that's why you have 1 left.
Oh, okay.
Yeah?
Mm-hmm.
So you have 2 of the cosine square, you take away 1 of the cosine square, that's why you only have 1 left. Okay? All right, so this is cosine of theta times cosine of theta. So cosine of theta times cosine of theta is cosine square of theta, as you can see there. And then if I have sine square, a negative sine square, well, the factor of sine square is sine times sine, right? To get a negative, you need a negative sine of theta times a positive sine of theta, like that. Okay. So this is the difference of square. Basically, you get the same value, 1 plus, 1 minus. Think of it like the conjugate, very similar to it. So cosine of theta times cosine of theta is cosine square. Sine of theta, a negative sine of theta times sine of theta is negative sine square of theta. Your sum, your middle term, is going to cancel out because you have cosine times sine, so that's a positive cosine theta, sine theta, and then you have a negative of the same thing. It will cancel out, okay? And then on the bottom, I have cosine of theta minus sines of theta, like that. Well, this cancel out. Okay? You can cancel factor, but you cannot cancel terms, okay? When you have a difference or a sum. Because you are able to cancel out your denominator, and this is the one that caused your denominator to be 0, you can then now try to plug in pi over 4 one more time, okay, to see what you get. So I have cosine of pi over 4 plus sines of pi over 4. As I plug in the value, I don't have to write limits anymore, so make sure you know that. So cosine of pi over 4 is root 2 over 2. Sine of pi over 4 is root 2 over 2. Since the denominator is the same, I can write that as a 2. Yeah? If you don't have a number in front of your root, you can put a 1 there. Because remember, when you add, you're going to add the coefficient. Okay? These are like terms. They're both square root. So you have 1 square root plus 1 square root. That's 2 of the square root of 2. So the 2 will cancel, right? The 2 here and the 2 outside cancel. So your answer is the square root of 2. Questions on that? Okay. We're going to move on to the next one so that we can evaluate. Now, hopefully you're going to see that when you do your homework. And we have tutoring yesterday, so a lot of you asked me the same question. When you have that absolute value, please know that absolute value means you have 2 pieces of the function, okay? 2 lines, one with a positive slope and one with a negative slope, so it's going this way. So what you want to do is you want to break it up. That way you can see both functions, okay? So we're going to start this by breaking this up first. So I'm going to rewrite this. This is f of x, okay? And then this one, if I were to, absolute value mean you have, it's a distant. It's a distant and number is from 0. So if, let's say, whatever that is, right, the distance can go from the negative side to 0 or from the negative side to 0 or from the positive side to 0. So we can start with the negative side first, like that. Yeah. I'm going to write this. I'm going to rewrite this here. I'm going to factor that out just so we have the space for it. X minus 6, x plus 6. And when I break this up, this occurred when x is less than 6. So this tells me I'm going from the negative side, anything less than 6, okay, on the left of 6. And then the other one is on the right, the positive side. So that's x minus 6. So you have a negative x minus 6 and a positive x minus 6. You have to break that out into two pieces of a function. For this piece is anything on the right of 6. And then at 6, you have 0. So 0, that's when you are at 6. Okay? Let me write that in the middle so we can see it. And this is your pieces of the function. I might have to move this down here. I'll move this down. And when you look at this, this tells you this is your left hand behavior, and this is your right hand. So you're looking at your limit from the left and from the right. Okay? You keep looking at the limit from left and right. So now I'm going to look at my limit from the left first. Okay? So the limit as x approach 6, because that's what I want. Notice this tells me I want to find the limit as x approach 6 from both sides. But because I have two pieces of the function, I need to look at it from each side. So the left side is this one. This function, if I were to take a look at it, notice you can see now I can then cancel things out. I can cancel the x minus 6. So what I'll get when I plug in the 6 is I'll get negative 1 over 6 plus 6 is 12. Negative 1 over 12. That's my left hand. Are you guys good? Yeah? Whenever you see absolute value, you got to break that out into two pieces of the functions. Now we're going to take a look at the one on the right. So this is going to be x minus 6, x minus 6, x plus 6. So this will cancel out. And what I'm getting back here is 1 over 12. Now the problem that we have is the left limits and the right limits does not agree. Do you guys see that? They don't agree. So then that means I can claim now, I can make my conclusion that the limits, therefore, that 3 dots mean therefore, the limit as x approaches 6 from both sides of your function f of x does not exist. Okay? Or we can write that as D and E. Is D and E. How are we doing? Any questions on that? Yes.
So basically when there's an absolute value, you have to make a positive one and then a negative one?
Yes.
Okay.
Because absolute value, in essence, is the V-shaped function. Is when you have a positive slope of 1 and a negative slope of 1. Yeah? So that's what this is the parent function for absolute value. So you have to consider, well, here's one line that have a positive slope, and here's another line that have a negative slope. So once you break it out, that's what you want to see, an equation with a negative slope and one with a positive slope. Okay? You cannot cancel x minus 6 here and x minus 6 down here at the beginning, because this is absolute value. It's not a parentheses. You got to break out that absolute value and change it to parentheses first. All right, we're going to go on to the next one. Go ahead and take a look at example 6, please. They ask you to evaluate the limit as x approaches 3. So do a quick check. You can see that this is 3 squared. That's 9. 9 plus 3. Oh, that works, right? Yes? That's 9. 9 plus 3 is going to be 12 minus 2. That's 10. So that works. Do you guys see that? Yes? So that just means that I don't have to cancel anything. I don't have to factor out anything. Do you guys see that? So sometimes it helps if you just start by plugging it in. Plug in the number and check first. Okay? So in this case, I don't really have to factor. Just plug it in for me and see what your answer is. You guys see that? Go ahead and do that. So in this case, we have 3 cubed. That's 9. 9 times 2 is 18. And then that's a minus 5. Alright. So that's 27. 27. I'm going to combine these. So that's going to be plus 13 over 10. So that's going to be 40 over 10. So I got 4. How are you doing? Questions on that? Yes? Now, can you factor? Yes, you can, if you remember factor by grouping. But we don't need that because this is not indeterminate form. So I don't need to rewrite anything. Do you guys see that? And that's why the first thing you always should try is to plug in the value and check. Yes? Questions on that? All right, we're going to move on to the very last example, and then we should have time to do the work for today. Okay? So go ahead and take a look at example 7, please. All right, let's take a look at example 7. I want to evaluate the limit as x approaches -2 of h of t. So notice, I want x to approach -2. By writing it this way, you want it to approach 2 from both sides. You guys see that? So that means if you have a piecewise function, you need to identify where's the left side of -2 and where's the right side of -2. Do you guys see that? Lucky for us, we don't have absolute value, so we don't have to break them apart. You guys see it? So looking at this one, this is t less than -2. So this is left right here, right? This is the left hand. That's the left hand limit. And then x greater than -2, that's your right hand limit. So what I want to do now is I want to find the limits from the left of -2 and from the right of -2. So we're going to have to break that out. So this is the limit as x approach -2 from the left side. Okay? And I'm going to write just the left function. I don't want to write h of t because there's like 3 of them. So you're going to have to pick the correct one, all right, which is the one on the left. So that's going to be 3t plus 3. Now, because this is your expression, I can just plug in the -2. It's not a ratio, so I don't have to worry about indeterminate forms or 0 in the denominator. So I can just plug that in. Remember, as you plug it in, right, you do not write LIM anymore. Okay, so that's going to be -6 plus 3. That's going to be a -3. Go ahead and get me the right-sided limit, please. Go ahead and get me the right-sided limit. Okay, so take a look at the one on the right. Whenever you have a negative value that you have to substitute, put parentheses around it, yeah, around the value x. That way it's easier for you to write your negative 2 in there. So you should have 4 plus 2 minus 9. Yeah? So that's going to be 6 minus 9 is going to be a negative 3. As you can see, my left hand limit is a negative 3. My right hand limit, as x approach negative 2 from the right, is also a negative 3. Because the left limits, the left hand and the right hand limits agreed. The limits from both sides does exist and is approaching negative 3. So I can write that. The limit as x approach negative 2 from both sides of h of t is equal to negative 3. Okay, so therefore, the limit as x approach 2 of h of t is going to be negative 3. Any questions on that?